Welcome back to the channel. Today's video, I'm going to take a little bit of a break and we're going to do something slightly different. Instead of me programming the data analysis, we're going to use ChatGPT and in particular one of their specific GPTs, the data analyst. And so we're going to take some data we've looked at before, some analytical data, and see how well it does with some basic tasks such as importing data, reading some of the data, some plotting, and some simple analysis of that data, just so you can see how the future of data analysis might look. At this point, almost every UI where you could do data analysis, such as Excel and Jupyter, Databricks, has some sort of interface with an AI assistant built in. And it could be something as simple as asking for coding help to helping you debug error messages and much more. And so you might as well get used to how to interact with these sorts of tools, as they can oftentimes make your job a little bit easier, but asking that question is key. So let's get started. So now I'm showing you the spreadsheet of the data we're going to take in. We have our sample IDs, which is this alphanumeric. We have a component column, which contain the names of all of our analytes. And from column C and beyond, we have our visible and IR data as numerical values. And so we're going to first import this data and then begin asking a few questions of the GPT and seeing what it does with the output. Let's get started. So here is the data analyst GPT. The first step is to just look for our data file. And so for me, the data is this near IR data. And so all I've got to do is drag and drop there, and I could begin asking some questions. And so we do want to give it a little bit of context. It might be able to read some of that from the metadata from the file, such as the fact that I told it it's near IR data and that it is a CSV. But I also want to provide some extra information. This is near our data on drugs of abuse and their impurities. And I know because this is NIR, I wanted to apply standard normal variate to throw data and then just plot each spectrum and then sort the spectra based on similarity to glucose, just so we can have some starting point for this analysis and we can see how it handles multi-step commands. Let's talk about what it's done so far. So we have our command and then it runs this checklist, and then it produces this numbered list, load the NIR data, apply the SNV, plot the data, calculate the similarity for each, and then sort those spectra based on that. And so we can see that it has identified some structure of the data. We have the sample ID and component column, and then it recognizes that we have our wavelength data between 350 and 2500 nanometers. And so it does then generate some code in Python, so you can see how it's importing this data. It's using read CSV in the background, so it's something we would likely do, and then allowing a preview of the data by using the head method. We see that next it is also plotting the transformed data, the SNV transformed data. And so here it is computing standard normal variate by computing the mean and then subtracting the standard deviation, or computing the mean and then dividing by the standard deviation, and then inserting the component column and sample ID column back into the data at the beginning. And so this still looks pretty good. Actually, this insert's a clever way to ensure that those two columns, that metadata, is at the beginning of the data frame. So probably something I'll also adopt moving forward, particularly when I need to remove the non-numerical data from my data frame, or if I want to do some of the transforms. We do get an error, and it just a timeout error. So perhaps it was the GPT was busy. We can see that it was attempting to plot using matplotlib, iterate to iterate through the data and then produce it. So it looks like it just ran out of time, but then the system stopped. So let's see if we regenerate what happens. So the time I'm analyzing this, it is 10:30 Pacific. So I don't imagine it should be super busy. I would get if it was like prime time in the Eastern time zone. That does not appear to be the case. So now it's redoing all of that analysis in the beginning. And so while asking multi-step questions is maybe more convenient and very human, perhaps breaking this down to smaller components would have been more advisable. And you see why. If we need to regenerate, then it's going to run through all of that analysis. When the first 60 to 70% was good, and maybe we could have just written a line for the final bit of data. So we'll see how it handles this. It looks like it was fine. It just finished computing before, or it timed out before it finished computing. So, just things like that where The system has its own sort of checks, and we will see how it does this time. Okay, so it timed out again, and it is now offered to plot a subset of the spectra or try to optimize the plotting process. So this will be interesting to see what it chooses to do. It says, let's start by plotting a subset of the spectra to ensure that the transformation and plotting are working correctly. So it's attempting to troubleshoot itself. It is plotting a subset. So here is the standard normal variant. It's applying that, and we will see how it handles it this time. Okay, so now it's attempting to plot separately. So I'm gonna get rid of this, and I'm gonna regenerate, but I'm just gonna stop it. And instead of it attempting to plot all this, because this might be a matter of how much, the time of day, what sort of compute resources are available, because I do believe it should be able to plot all this data. But instead of doing that, let's go to another technique. Let's just perform PCA and plot a scatter plot of the first two principal components of this data. Again, it gives us our numerical list. It's inspecting the data file again. It was loaded again. And this time I did not tell it to perform SNV. So it's probably learning that from the earlier step where I did ask it to do that pre-processing transformation. And then so it will do that and then perform the PCA and then plot those first two components. Again, we can look at the code. We see it's reading it into the memory of the computer again. And now we have our principal component of those two plots. And I do like that we could see the code that was used to produce this. And so if we wanted, we could just copy this into our own environment and run it again and just update the path to point to where our data file is. And so this looks pretty good. I'm assuming it's correct. I could certainly go and verify that. But I want to do something else. I want to ask it now, take this plot and add the annotations based on the component column. Okay, so to me, the text is a little bit small. And so we can see that it has now added the annotations based on that component column. And what I want to do is now tell it to perform some sort of clustering on this data based on the scores data. So let's perform k-means clustering on the scores data and change the point color to match the k-means group cluster. And so in this case, I did not tell it how many clusters to compute. Okay, so it has computed 5 clusters, 0 through 4. And we can see here, we've got caffeine. Up there, we have what looks in this group to be some sugars, vitamin C, some sugar, and then vitamin C. In this group, we have non-dairy creamer, lactose, wheat flour, oxazepam tablets. So an interesting group that's sort of coming together there. And we can kind of see how it's doing some of this analysis. Let's ask, how did you determine the number for K in k-means? So let's see. We did not tell it how many clusters to identify. Did it just use the default, or did it perform some other method such as elbow or silhouette? And before it's even finished, we can see that it was arbitrary. So it is now suggesting some other techniques. Would you like to determine the optimal number? Yes. And in this case, let's use the silhouette analysis. And so this is one of the cool areas because there's quite a bit of analysis happening outside of the hiccup in the beginning, where we could just use text and ask the proper questions to begin doing some analysis. And again, we're generating the source code the entire time. So to me, this is maybe a convenient way to sort of try to learn how to do this or get exposure to other techniques, particularly when you're just getting started or want to try to move through exploring data quickly. And so here we can see we have an optimal number at 3. We're looking for the highest silhouette score. And so if you'd like, we can now perform the k-means, again, using the optimal number and update the scatter plots accordingly. Yes. And so again, it now also builds context from what we've asked before. So now that we have determined the optimal number for K and we have our data, we have the source code, we can then update our plot above for this analysis. Okay. Update the plot to make the points more visible and the text larger. Okay. Well, it definitely looks like the points are larger. It's easier to see the green, the purple, and the yellow. It's just a really difficult color, but it's more obvious where these groups are being clustered. And lastly, I want to see something that's maybe more of a stretch. I want to determine if it can do hoteling t-squared on these clusters, and then also add that confidence ellipse to the plot. Again, this is a fairly complex set of tasks, and let's see how it does. And this would be one of those cases where writing the code out myself could take a while. A hoteling t-squared conceptually is not super complex, but the code itself is multi-step, and we'll see if we get another error. Okay, it looks like it needed another module. I recall when I performed this in Jupyter, I did have to add the patches module into matplotlib. So I'm guessing the base environment did not have everything needed to perform this analysis, especially around adding the ellipse to the plot. Yep, there we go. Okay, and so there you have it. You can see that we have computed the 95% confidence ellipse for each of these clusters, and that it's way more obvious now that it has also updated the color scheme to blue, green, and red. I apologize for those who may have a slight visual impairments, but we can see how distinct some of these clusters are. If we have certain regions we're concerned with, this is a good way to determine that. Instead of looking at all the chemical fingerprints, we can use PCA and hoteling t-squared. We could do all sorts of other things as well to gain some insight. And this was just me asking a few questions. Of course, there's others where we can maybe build supervised models or other visualization. Notably, some of the performance could be limited based on compute resources at the time, how busy this GPT is when you're doing your analysis, but also it does give you that source code in case you do want to go back and do that analysis or verify the results. Of course, you should always verify these results. For some of these, maybe the outcomes are quite simple, so I do challenge you to take some data you're familiar with and run it through some analysis like this. But again, take that source code back to your own environment, run it, perhaps have some unit tests ready, and see how robust it is and accurate for your particular assessment. In any case, I hope this video was helpful. I'll probably do a few more of these with other data sets, ask us some other simple questions, some more challenging questions. And if you like that, like, comment, subscribe, and I'll see you in the next one. Peace.